Okay, so now we're going to talk about Cepheid variables. Now, Cepheid variables are actually a type of star, okay, and they're a star whose brightness varies, but they vary in a very unusual way. The brighter, the bigger and hotter the star, in other words, the more luminosity it has, the longer it takes to actually go through a cycle of varying in brightness. In other words, these stars get brighter, their brightness, if we were to graph their brightness over time, they get bright, then fainter, brighter, fainter, brighter, fainter. Now, the time it takes to go from one brightness peak to the next, that's called its period. Another variable star might vary like this. So its brightness is not varying as much, and the time it takes to go from maximum brightness to maximum brightness again, that would be its period. And you'll notice that this star here has a longer period than this star. Okay, so that's what we mean by the period of a variable star. What Henrietta Leavitt realized was that these particular types of stars called Cepheid variables, their period is directly related to how luminous they are. In other words, how bright, their absolute brightness. And this is a graph of the results of what Henrietta Leavitt actually discovered. She plotted the luminosity of a lot of these variables against their period and realized they all fall on a pretty straight line, which is telling us that the longer the period, the greater the period. In other words, the greater the time between bright peaks, then the brighter the star is, the brighter the actual star is. And so that gave physicists a way of identifying a star and determining exactly how bright it was. In other words, if you're right next to it, how bright it actually would be. So it allowed scientists to identify specific stars out in galaxies whose brightness they actually knew, how much energy they were actually producing. And these stars are often referred to as standard candles. And a standard candle is a star whose energy, you know how much energy it's producing, you know how bright it would be if you were, say, 1 million kilometers away from it. You know how bright it would be. So you know a lot about a standard candle. So these Cepheid variables are actually standard candles. And that means that if we knew that a star had a certain period, for example, it had a period of, say, this value here, it was 20 days, let's say, which meant that it would have a luminosity of this value. So that's its luminosity, which tells us how bright the star actually is. So we know how a star the bright is if we're close to it. But if that star, if we observe that very star here in a distant galaxy and it appeared quite faint, we know that that is because it's further away. So we know that if we can find a Cepheid variable and we can measure its period, we can determine its luminosity, and by then, if we know its luminosity and how bright it appears to us, because the further away you are from a luminous object, the fainter it appears. If we know how bright it is when we're up close to it, and we can see how bright it is from our observational position, we can work out how far away it is. So Cepheid variables are actually a way of allowing us to determine the distance of galaxies that contain these stars in them. And because these Cepheid variables were found in many of these galaxies, allowed us to determine the distance to these galaxies. So it was a very, very important breakthrough in determining how far away these galaxies were, which fed into Hubble's idea that if we know how with the redshift and the expanding universe, we were then able to determine how far away those galaxies were. And so it all came together very neatly. Okay, thank you.